So, a very good afternoon, students. Welcome to the class. We'll wait one more minute for some more students to join. Then we'll begin with our class. Okay. So, till then, let me know I'm clearly audible to you all and the screen is clearly visible to you all. So, please answer me in the chat box whether I'm clearly audible and the screen is clearly visible to you all. Okay. Okay. Okay, students, I can see that there is no disruption. So we'll begin with our today's class. Once again, a very good afternoon. Well, so in our previous class, like in last few classes, we have started with the chapter sequence and series, right? We covered so many topics. And today, in yesterday's class, we covered our last topic, that is method of difference, isn't it? So in our today's class, what we will do is we will revise all the topics that we have learned and we'll solve few previous year JEE questions, fine, on the concept that we have learned. Well, so this will be the content of our today's class. Okay. So, not wasting much of the time, let's begin with our class. Next. So, well, everyone brush in the morning, right? So, what happens with brushing? When we brush, it makes us active, right? Like we'll be very in the sleepy mood, but when we brush, we'll become active. So similarly, let's brush our brain and make it active, and let's make it remember the things that we have learned previously, so that we can use that in our today's problems. Okay, so it will be easy for you all if you revise the concepts, and you can easily apply that in the problems, right? So today we'll revise few things. So before revision, let me know how much you remember the previous class concepts and all. So let me ask one question. Okay, assume A1, A2, so on up to AN. Okay, capital A. And this is B. Let A and B two terms, fine? And A1, A2, A3 up to AN will be the N arithmetic means inserted between A and B, okay? These all are in the arithmetic progression, and N arithmetic means, that is A1, A2 up to AN, are inserted between A and B. Then how do we find R the term? Tell me, AR is equal to R arithmetic mean. How do we find R arithmetic mean? This we have discussed 3 classes ago when we were discussing arithmetic mean concept, isn't it? So answer in the chat box. What will be AR is equal to? So AR will be A1, A is A. Second term will be what? A plus D, right? D is the common difference. This will be A plus 2D. So AR will be what? A plus RD, right? Rth term, correct? So what is D here? We found a value of D here, right? In the terms of A, B, and this N, isn't it? What was the D value that we found? Tell me. So D value that we found was B minus A divided by N plus 1. So our AR will be what? AR will be equal to A plus R into B minus A divided by N plus 1. Okay. This is one of the concepts that we learned previously. Fine. So try to remember the concepts that we learned previously. Okay. So let's revise it once again. So let's begin. Well, let's start with the arithmetic progression. So our first class we started with the sequence and series, right? We have seen what is sequence, what is series, and we have seen progression also. And in that, here in this class we studied like about 3 progressions, right? Arithmetic progression, geometric progression, harmonic progression, and arithmetico-geometric series, correct? This 3 and there's another one, isn't it? So we'll start with first one, that is arithmetic progression. So what is arithmetic progression? It's a progression or it's a sequence where two consecutive terms will always have a constant difference. So consider any two consecutive terms, the difference will be same in that case. Okay. Well, so it can be represented as a plus t, a plus 2d, a plus 3d, so on. So if this is the arithmetic progression, then its nth term is given by a plus n minus 1 into d. Okay. So whoever not there in the first class, please do concentrate here and listen to it, okay, properly. Well, and if Tn, this is the nth term, the common difference will be given by d is equal to Tn minus. That is difference of two consecutive terms. Okay. Well, nth term from the end. If L is the last term, see here a plus t, so on, up to L we have, and L is the last term. From here, we are finding nth term, say Tn, T dash N, then it will be given by L minus n minus 1 into D, okay? So nth term from the last term is given by last term minus n minus 1 into D. Fine? And sum of the first n terms, yes, it's the important formula. Sum of the first 10 terms is given by n by 2 into 2a plus n minus 1 into D. And if last term is given to us, if we know first and last term and total number of terms, then we can make use of this formula. That is n by 2 into a plus n. So is it clear to you all? Any doubt in this? Tell me. Is this 4 points clear to you all? We have just seen what is the nth term, common difference, nth term from the last term, and the sum of the first 10 terms. Answer me in the chat box. Is it clear to you all or no? Okay. And the last is a formula for nth term itself in the terms of Sn. So it will be given by Sn minus Sn minus 1. Okay. Is it clear? So any doubt in this? Any doubt in this? So here Tn also can be given by 1 by 2 into Tn minus k plus Tn plus k. What is this Tn minus k, Tn plus k? So if you consider Tn, these two terms are terms which are equidistant from this Tn, okay? From on either side. Okay? They are same distance from this Tn on either side. If we take sum of those two terms and divide it by 2, we will get value of Tn. That's what they have mentioned here. So is this clear to you all? Any doubt in this? Anything that need to be explained? Let me know in the chat box if you have any doubt. Okay. Well, very good. If this is clear, then we'll go to the next part. Next is geometric progression. So what is geometric progression? Consider a sequence and consider any two consecutive terms. If ratio of the consecutive term is constant, then we call the complete sequence as what? Geometric progression. Okay. Now, a geometric progression can be represented as AR squared. Okay. Here A is the first term and R is a common ratio. We know that. And the nth term of the geometric progression is given by Tn is equal to A into R raised to n minus 1. Fine? This is the nth term of the geometric progression. And if you want to find the nth term from the last, so similarly, if AR squared up to L is the geometric progression, and we have to find nth term from last term, then what will be the term? It will be equal to Tn dash equal to 1 bar, L bar R raised to n minus 1. Okay. Well, remember you have to remember these formulas, okay? or even arithmetic progression formulas, geometric progression formulas. We're gonna make use in the problems. So please do remember them. Fine. And next is sum of first n terms. Sum of first n terms is given by a into 1 minus r s to n divided by 1 minus r. Okay. When r is not equal to 1. But if r is greater than 1, we can also write this as what? A into r s to n minus 1 by r minus 1. If mod r is lying between 1 and minus 1, that is r is lying between 1 and minus 1, then we can write the sum as what? That sum as a into r is 1 minus r s to n divided by 1 minus r. Okay. And if mod r is less than 1, okay, if mod r is less than 1, we can find the sum of this GP up to infinite terms. Okay. We can find sum of this GP up to infinite terms only if this mod r is less than 1. Okay. That is r lying between minus 1 and 1. Okay. And that is given by a divided by 1 minus r. And in my previous classes, I also explained why mod r is, why we can find sum to the infinite terms only when mod r is less than 1. Why can't we find when r is greater than 1? I have explained it in the previous classes, right? Why? Tell me. Why can't we find when r is greater than 1? Why can't we find sum up to infinity terms? Why? Because when r is greater than 1, what happens to GP? It will be an increasing GP. Terms will be in the increasing order. So if you find sum of that, the sum will be infinite, right? If you consider infinite terms and find sum, it will be infinite. But when r is less than 1, the GP that we will get, it will be a decreasing GP. Terms will be in the decreasing order. So if you find sum, you will get a finite value. That's the reason mod r should be less than 1. Okay. So is it clear to you all geometric progression? Any doubt in this? Let me know in the chat box if you have any doubt. Yes. Do respond me in the chat box, okay? Okay, there is no doubt. We'll go to the next part. Fine. Next. So next is arithmetic mean. Well, what is arithmetic mean? Arithmetic mean means it's an average value. Okay. If we have three terms A, B, then we call this capital A as the arithmetic mean of A and B, and it is given by A is equal to A plus B by 2. Okay. So a single arithmetic mean between A and B is given by A plus B by 2. What if you have n arithmetic means inserted between A and B? This we discussed in our first slide itself, right? If n arithmetic means are inserted between A and B, then its rth term can be given by A plus R into B minus A divided by n plus 1. Okay. Here D value is nothing but B minus A divided by n plus 1. Fine. And there's one more result that we have. Sum of this n arithmetic means is given by n into A plus B by 2. So what is this A plus B by 2? It's a single arithmetic mean between A and B. Okay. So sum of the n arithmetic means is given by n into a single arithmetic mean between A and B. Is it clear to you all? Any doubt in the arithmetic mean? So the thing that I have to remember in arithmetic mean is what happens when n arithmetic mean is inserted between A and B. It's arithmetic mean formula and this result. Okay. So these are the things that you should remember here. So is it clear to you all? Any doubt in this? Anything that you need to be revised? Please respond in the chat box so that I can know if people are understanding. Okay. Cool. So if there is no doubt, we'll go to the next part. Next is geometric. So what does geometric mean? So G is said to be geometric mean between A and B, and it is given by G is equal to root of A into B. Okay. If we have A, G, and B are in GP, okay. If we have three terms in GP, that is A, G, and B, then we call G as a geometric mean of A and B, and we give it's given by G is equal to root of AB. Fine. This is the value of geometry. Like it's a value when single geometric mean is inserted between A and B. So now what happens when n geometric means are inserted between A and B? So when n geometric means are inserted between A and B, R the geometric mean value is given by GR is equal to A into B by A whole raised to R by n plus 1. Okay. Here common ratio value will be what? I write it as common ratio. So common ratio will be equal to what? B by A whole raised to 1 by n plus 1. Okay. And even here we have one result, that is product of this n geometric mean will be equal to single geometric mean between A and B to the power n. Okay. You can observe here root AB is a single geometric mean between A and B, and raise that to the power n. Then this will represent what? It will represent product of geometric means. Okay. So is it clear to you all? Any doubt in this? Let me know if there is any doubt in the chat box. Come on, guys, reply in the chat box if you have any doubt. Okay. Cool. So if there is no doubt, we'll move it. We'll go to the next one. Well, next is harmonic mean. But before discussing harmonic mean, we should know what is harmonic progression, right? Well, if A1, A2, A3, so on up to AP, then reciprocal of these terms, that is A1 by A1, 1 by A2, 1 by A3, so on up to 1 by A1, we call it as what? The sequence formed by taking reciprocal of the terms of AP, we call it as harmonic progression. Okay. So harmonic, what will be the harmonic mean? It is nothing but if A, B, C are in harmonic progression, then B is said to be harmonic mean between A and C, and it is given by 2 into AC divided by A plus C. We discussed this in our class, how we have got this 2AC by A plus C and all. So we won't be discussing its derivation and all, but try to remember it, okay? So if A, B, C are in HP, then B is the harmonic mean, and it is given by 2AC divided by A plus C. Fine? Okay. And what if n harmonic means are inserted between A and B? In that case, just convert that given harmonic progression into arithmetic progression and solve it using arithmetic progression formula. Okay. So that will be the easiest approach that we can have. Whenever harmonic progression is given, convert it into AP and solve it. Well, so if this is clear to you all, we'll go to next part. Yes? Okay. So the next way is relationship between AM, GM, and HM. That is relationship between arithmetic mean, geometric mean, and harmonic mean. Okay. If A, G, H are respectively arithmetic mean, geometric mean, harmonic mean between A and B, we have A and B, and A, G, H are what? Arithmetic mean, geometric mean, and harmonic mean. Then there is one relation between these three terms. It's given by G square is equal to A into H. Okay. And they have given one more condition, that both be positive. both being positive. Why they have to be positive? See, because it's a square value, right? If one of the term is negative here, a into h will be what? Negative. Then g square cannot be negative. It doesn't exist. So that's the reason both a and b should be positive. Okay. And what is one more relation? The one more relation is, yes, arithmetic mean is always greater than or equal to geometric mean, and it will be always greater than or equal to harmonic mean. Okay. Just remember this. It's an important relation, and we will make use of this relation in the upcoming problems. Okay. Remember it. So is it clear to you all? Any doubt in this? We are just revising all those concepts that we have learned. Okay. So just glance over it. Try to remember all the formulas that we're gonna make use further. That's why. So if this is clear, we'll move ahead. So after relationship between AM, GM, HM, we learned about what? Arithmetico-geometric series, right? Arithmetico-geometric series. Correct? Yeah. So in this, we have also seen it's some of the first n term formula and all. But as it is very hectic, what we have done, we made use of certain steps to compute the SN value. Correct? What were the steps? Steps were, first was to write a SN as it is, then that multiply that SN with a common ratio we have. Correct? And then, okay, before this, tell me what is arithmetic geometric series? It is nothing but it's a combination of arithmetic progression and the geometric progression. First terms, if it is C, for example, 1x squared plus 2, okay, 1x plus 2x squared plus 3x cubed plus so on, okay. You can observe this 1, 2, 3 all are in AP, x squared, x cubed are in GP, okay. Such series we call it as arithmetico-geometric series. And to compute sum of that such series, we make use of these steps. Okay. The first step was what? To write Sn as it is, then multiply that Sn by R Sn. The third step, we subtracted both, subtract Sn minus R Sn. If we are able to get a geometric series, then we compute it using the formula. If we're not able to get any conclusion, we're not able to conclude it as any series, then we repeated the step. Correct? So this is the procedure to solve the arithmetico-geometric series. I hope you are remembering it. Okay? Well then. So this is clear to you all, right? Cool. This is clear to you all. We'll go to the next one. Next one was what? Next one, summations, okay? We studied about the summations, right? It's given by the symbol sigma notation. So in this, we studied properties of summations. Correct? And we also seen some special series. Isn't it? And using this special series, we solved so many problems, right? I hope, yes, special series like summation of k. K is equal to 1 to n. What is this? It is sum of the first n terms, right? The k value is varying from 1 to n. It means we are considering first n natural numbers. Its sum will be equal to what? It's equal to n into n plus 1 by 2. And we also discussed about sum of the square of first n natural numbers. It's given by n into n plus 1 into 2n plus 1 divided by 6. And then we discussed about sum of the cube of first n natural numbers given by n square into n plus 1 whole square divided by 4. We discussed these formulas. So these formulas, whatever we have, we're gonna make use of these formulas in our problems, okay? Remember it. Okay. So is it clear to you in summation? There's some more summation of k raised to 4 and we have that, but these are the important one that we're gonna make use of. Okay. Any doubt in this? Anything? Well, so after summation, what we discussed the method of difference, right? Method of difference. When do we make use of method of difference? When our given series is neither solvable by AP, GP, AGP, or using summation. So if you are unable to solve a given series using any of this method, you make use of method of difference, okay? In method of difference, what we will do? A Sn will be given to us. Yes, we'll write Sn as it is. Some terms say we'll have some terms here. And after that, we'll write Sn again, but we push one term towards the right. This first term we write below the second. After that, what we will do? We'll take difference of this both. Okay. When we take difference of this both, we'll get 0 here and we'll get some terms. Except first and last term, we get some terms in between which are in either AP or GP. Okay. So after that, we make use of the formula and we compute further. We solved such problems in our previous classes. Okay. I'm just explaining the procedure, how we did it. Okay. But this is one of the method of difference method. In the second part, there's another method, like the second part of method of difference, where we written the rth term in such a way that we have splitted it into two parts, so that if we write T1, T2, T3, some of the terms get cancelled. Okay. So when we add them, some of the terms get cancelled and we got the value of Sn in that case. Okay. We solved such problems in our last class itself. I hope you will remember it. So these are the concepts that we covered in our complete last 6 classes. Okay. These are the concepts involved in sequence and series. So do you all have any doubt in these concepts that we covered previously? If you have any doubt, then please let me know in the chat box. Okay. So YouTube students, please do reply in the chat box if you have any doubt. And the Zoom students, please reply here. Well, okay. So if there is no doubt in this problem, then we'll move ahead. The concepts, okay? We'll go to the problems. Next. Well, this was the problem I had given for the homework, right? In last class, this was the last problem, and I told you all to solve it at home and try it. Anybody solved it in the home? And anybody got the answer? Let me know in the chat box if you have solved it. Okay, so no issues if you haven't solved it. We'll solve it again. So let's see the question. The question says that if alpha, beta are the natural numbers such that 100 raised to alpha minus 199 into beta is equal to 100 into 100 plus 99 into 101 plus 98 into 102 up to 1 into 199, then the slope of the line passing through alpha and beta, alpha, beta and origin is given by. So what will be the value of that? First tell me what will be the slope of line passing through alpha, beta and origin. Yes, origin, by origin means 0, 0, right? What will be the slope of the line? Tell me. Let me know in the chat box. What is the slope of the line? Answer me in the chat box. Okay. Slope of the line is given by what? Y2 minus y1 divided by x2 minus x1, right? So here it will be beta minus 0 divided by alpha minus 0. It's going to be beta by alpha. Okay, this will be slope of our line. To find slope of the line, we should find alpha and beta value. Okay. So let me write a series here. It's given, right? 100 is to alpha minus 199 into beta is equal to. Now look at this first term, okay? It's 100. Here it's 99. It's 98. So on up to it's 1. What's happening here? It's 100, 99, 98, so on up to 1. What's the pattern that you can observe? What is happening to the terms? Tell me. Let me know in the chat box. What's the pattern of like what actually what is happening to the terms? First term is 100, then it's 99, then it is 98. It's decreasing, right? Step by step. In every term, minus 1. It's decreasing by 1. Correct? So, what can I write here? I write this as 100 only. 100, say, minus 0. Next term. I'll come back to the second term also. But first, let's finish this first term of this. It's 99. I can write as what? 100 minus 1, right? Plus, similarly, I can write third term as what? 100 minus 2. Correct? Plus so on up to it's 1. So it can be written as what? 100 minus 99, right? Correct? Now look at this. Look at the second terms, okay? It's 100. Next is 101, 102, so on up to 199. What is happening here? What is the pattern that you can find here? Tell me. Tell me in the chat box. Come on, students, be active and answer in the chat box. It's a simple question. I'm just asking what's the pattern you are finding here? It's increasing or decreasing? Let me know. Let me know in the chat box. Okay. So your terms are increasing, right? So if I write this as 100 plus 0, this will be what? 101. It can be written as 100 plus 1. This can be written as 100 plus 2. So on up to it can be written as 100 plus 99. Correct? So observe here. Here 100, 100, 100 everywhere. 100 is constant. What is varying? These terms are varying, right? 0, 1, 2, so on up to 99. So here hundreds are constant, but the varying terms are not 0, 1, 2, 3 up to 99. So how can I write it? I can write it as summation varying from 0 to 99, 100 minus k into 100 plus k, right? Correct? I can write like this. Now tell me next step what I can do. Yes. What shall I write here in the next step? It is of the form a minus b into a plus b, correct? So what shall I write here? I can write it as a square minus b square, right? So it's gonna be 100 square minus k square, okay? So this will be equal to, well, it will be equal to what? I can write it as, now observe here, summation here is to the constant term. I just make use of properties of summation here and split it. So what will I get? I will get 100 square k is equal to 0 to 99 plus summation k is equal to, I get 1 to 99 k square. So okay, it is not plus, it is minus here. So it is minus. See, observe here. Here I wrote 0 to 99, but here I am writing 1 to 99. Why? Why am I writing like this? So let me take this to next page. So this is nothing but what was it? Yeah, 100 raised to alpha, right? 100 raised to alpha plus 199 into beta equal to, correct, minus. Well, so now observe here, this 100 squared is nothing but it's a constant, right? What is summation of constant is equal to? Yes, summation of constant, say from r is equal to 1 to n will be equal to what? Total number of terms into that constant, right? So total number of terms that we have from r is equal to 1 to n is n into k. So similarly here we will have total number of how many numbers we will have here from k is equal to 0 to 99. Tell me total number of terms here. Answer me in the chat box. What are the total number of terms from k is equal to 0 to 99? Yes. Okay. I'm expecting answers from you guys. It will be what? It will be 100, right? This 0, 1 term and 1 to 99, 99 more terms. So total will be 100 terms into 100 square, correct? Minus, yes, I took 1 to 99. I asked you the reason, right? Why it is 1 to 99, ma'am? Why it is not 0 to 99? It's not 0 to 99 because when you substitute k is equal to 0, what happens to this? It will become 0, right? So what's the question in it? It will be 0 plus substitute 1, 1 plus substitute 2, 2 square, so on, right? Up to 99 square. Well, this 0 has it doesn't have any value at all. So no need to consider it. So even though like substitute the value, it's gonna be 0. So I considered the summation from k is equal to 1 to 99. Okay. So we are adding totally 99 terms here. So what is summation of first 99 square of first 99 terms? Tell me. First 99 natural numbers. It's gonna be, yes. Okay. Let me know. I'll rub this and I'll write the formula. Observe here. Sorry. Okay. Summation of r is equal to 1 to n r square. So r square will be equal to what? It will be equal to n into n plus 1 into 2n plus 1 divided by 6, right? Correct? It will be equal to n into n plus 1 into 2n plus 1 divided by 6. So here what we have total 1 to 99, that is 99 terms. So in the place of n, substitute 99. So what we're gonna get? We will get 99 into 100 into 2n plus 1. So 2n plus 1 gonna be, tell me, 199, right? That is 2 into 99 plus 1. It is 199 divided by 6. Okay. So this can be written as 100 cube, whole cube, minus, 199. Remaining term, I keep as it is. That is 99 into, let's see, 900 divided by 6. Now just observe here. Just observe both the LHS and RHS of the equation. You can find something, right? 100 is to alpha minus 199 beta. Just observe both LHS and RHS and compare the terms. Just and compare the each terms. You will find the value of alpha and beta. So when you compare first term, it is 100 is to alpha, here 100 is to 3. So alpha value will be equal to what? Alpha value will be equal to 3. Now compare the second term. Here it is minus 199 beta. Here it is minus 199 into this term. 9,900 divided by 6. Correct? So when you compare the terms, what you will get? So its value will be nothing but 1650. Fine. So this is what you will get. This is not the end. We found alpha and beta value. But what is our ultimate goal? What they have asked us to find? They've asked us to find the slope, right? Slope of a line passing through this point. And found that the slope is nothing but beta by alpha. So what will be slope equal to? Slope will be equal to beta by alpha, which is equal to 1650 divided by 3. Fine. So it's gonna be what? So the answer gonna be 550. Correct? So of course it's 550. So the correct option is what? Correct option is option number 2. So is it clear to you all? Any doubt in this question? Any doubt? Let me know. Any doubt in this question? Let me know in the chat box. Okay. So if there is no doubt, then we'll move it. We'll go to the next question, okay? Next. Fine. So this was the question asked in the year 2021 JEE March Shift 2 section. Shift 2 session. Okay. So let's see what the question is. Question is 1 by 3 square minus 1 plus 1 by 5 square minus 1 plus 1 by 7 square minus 1 up to 1 by 201 whole square minus 1 is equal to. Well, now first look at the question. Tell me, can we solve this series using AP, GP or arithmetic-geometric progression or using a summation? Can we solve using any of these methods? Let me know. No, right? We can't solve using any of this method because we can't find such pattern which belongs to this belong to AP, GP or AGP. Okay. So what we're gonna make use here? We're gonna make use of second type of the method of difference that we discussed in our last class. Okay. So what is that? Actually, there we found the R term, the common, general term, right? After finding general term, what is the next step that we have done? Splitting that term in such a way that if we add all those terms like T1, T2, T3, so on, then the terms will get cancelled and we will get SN value. Okay. So that is the method that we're gonna make use here. Now, so tell me what will be the R term, TR is equal to. For that, we need to see the pattern, right? Observe here. Here we have 3 square. Here we have 5 square. Here we have 7 square. So what actually you can observe here? What kind of terms is these are 3, 5, and 7. What kind of terms these are? Yes, let me know in the chat box what kind of terms these are 3, 5, 7 are. Okay. So these are odd numbers, right? 3, 5, 7. All these terms are odd numbers. So what can I write here? I can write 1 divided by 2n plus 1. So the general term for 2. Okay. I can write this. Now, substitute n is equal to 1. You will get the first term. N is equal to 2. You will get the second term. N is equal to 3. You will get the third term. Okay. So this will be the what? Rth term. TR is equal to. I can write this as 1 divided by split it 4n square plus 4n plus 1 minus 1, right? So it will be equal to what? It will be equal to 1 divided by, just take 4n common, n plus 1. This both terms get cancelled. So this will be our, oh sorry, I written n r term, right? Why I have written n here? It should be r. It's r term, right? So it should be r square, r, and yes, this both will be r. 4r into r plus 1. Fine. What will be our second step here? Second step will be splitting our general term, right? We need to split in such a way that if we consider t1 plus t2 plus t3, so on up to tn terms, the middle term should get cancelled. Okay. So for that we have used one trick, right? When we have two terms in the denominator, we use the trick. What was that? Bigger minus smaller term trick. So among 1 by r and 1 by r plus 1, which is bigger term? Yes. Which is bigger term between 1 by r and 1 by r plus 1? Let me know. Yes. The bigger term is 1 by r, right? Because it's in the denominator. So we can write as 1 by 4 divided by 1 by r minus 1 by r plus 1. Okay. This is the term. Now find the t1, t2, t3 value. Sn will be equal to what? Sn will be equal to t1 plus t2 plus t3, so on up to tn, right? So find the t1, t2, t3 values. T1 will be equal to 1 by 4, 1 by yes, 1 only, minus 1 divided by 2. T2 will be equal to 1 by 4 into 1 by 2 minus 1 by 3, so on up to tn will be equal to what? 1 by 4 into 1 by 2 minus 1 by n plus 1. Okay, 1 by n, sorry. So you can observe here, this is minus 1 by 2, here we have plus 1 by 2. So both the terms get cancelled. Here minus 1 by 3, so in the next term we'll have plus 1 by 3, that will get cancelled. Similarly, if we continue like this until this term, or everything will get cancelled. So when we add these terms, those all terms will get cancelled, and we will remain with what? We will remain with Sn is equal to 1 by 4 into 1 minus 1 by n plus 1. Well then, here it is not up to first n terms, right? They are given last term. There's a full stop there. It's a finite series. They are given last term to us, but we know last term value, but we don't know what is n value. We need to find n value here, right? So what will be the n here? Our general term was what? 2r plus 1, right? So I just said 2n plus 1 is equal to 201. So what will be 2n is equal to? Let 201 be equal to 2n plus 1. It's an odd number. So 2n will be equal to what? 200. So n will be equal to what? 100. Correct? So our n is 100. The last term is 100th term. So it is sum of the first 100 terms. So it's gonna be S100 equal to 1 by 4 into 1 minus 1 divided by Sn plus 1. That is 101. Now just open this bracket. You will get 100 divided by 101 into 1 by 4. So it's gonna be what? 25 divided by 101. So now tell me which is the option. So our right option is option number 2. So is it clear to you? Any doubt in this? Any doubt in this question? Let me know if you have any doubt in this question. Nothing we have done. We have just considered the rth term. As we can't apply any of our previous method, we made use of our last method that we discussed in our previous class. That is method of difference one. That is taking rth term, splitting it in such a way that if we take sum of the terms, the middle terms get cancelled and will remain with some finite Sn value. Okay. So that's what we have done here. I hope this is clear to you all. Well, if it's clear to you all, we'll go to the next one. Well, we have next one more question. This question was asked in the year 2021 Feb shift 2 session. Okay. So let's read out the question and let's see. The question says that if the sum of first four terms of geometric progression is 65 by 12 and the sum of the respective reciprocal is 65 by 18. If the product of first three term of GB is 1 and the third term is alpha, then 2 alpha is, well, let's split this question, okay? What is first statement? The sum of the first four terms of geometric progression is 65 by 12. For that, we need a four terms, right? Four terms of GP. So I'll assume AR square, AR square, AR cube to be first four terms of GP. Now a question might arise in your mind. Ma'am, while discussing the properties of GP, you said that whenever four terms of GP is given, we have to consider A by R square, A by R, AR and AR square, right? AR cube, right? But here you have considered AR square, AR square and AR cube. Why so? So this question might arise. Well, we have to consider that formula only when terms are in, like when they ask the product of those four terms, okay? But here they asked sum, right? They asked sum. If we consider A by R square, A by R, AR and AR square, if we consider these things, then what will happen? If we take a sum of it, it's gonna be complicated, right? It's in the fraction part. So we'll not consider it. Well, now they have given that sum of this is equal to, sum of this terms is equal to 65 by 12. So just take A common, gonna be 1 plus R square plus R cube is equal to the respective reciprocals is 65 by 80. What is reciprocal of A? It is 1 by A plus 1 by AR plus 1 by AR square plus 1 by AR cube is equal to what? 65 by 18. Okay. This is sum of the reciprocal of those terms. Now just take 1 by A common. Yeah. 1 by A common. And take LCM of remaining terms. Sorry. Yeah. Consider remaining terms. What you will get? You will get 1 plus 1 by R plus 1 by R square plus 1 by R cube is equal to 65 by 18, right? Correct? You will get 65 by 18. Now take LCM of this. What you will get? LCM will be R cube. So here you will get R cube plus R square plus R plus 1 is equal to 65 by 18. We already know this value. R cube plus R square plus R plus 1. Correct? What is that gonna be? Oh, well, 1 by 8. Okay. Now, consider this as equation 1. And consider this as what? Equation 2. Just divide equation 1 by 2. Just divide equation 1 and 2. What we will get? When we divide it, we will get A square is A square R cube is equal to 12 by 18. Okay. So this is what we will get. So this will imply a square r cube will be equal to what? 4 by okay, 2 by 3, 2 by 3. Correct? So we got a square r cube is equal to 2 by 3. Now tell me what can we do further? Yes. Ultimately, we want value of what? We want value of alpha to alpha. Okay. Third term is alpha. We want value of third term. Okay. So from first statement, we have done this. They have given one more information to us. What is that? Product of three terms is equal to first three terms is 1. So A into AR into AR square will be equal to what? 1. So A cube into R square will be equal to what? 1, correct? So A cube into R cube. I can write it as A into A square into R cube is equal to 1, right? We already know value of A square into R cube, correct? Just replace that value here. You will get A into 2 by 3 is equal to 1. So A value will be what? 3 by 2. Fine. We got an A value. And we can easily find the R value also, right? Using this relationship itself. So it's gonna be what? It's gonna be 9 by 4. R cube is equal to 2 by 3. 2 by 3. So just cross multiply and let me know what is value of R. So R cube will be equal to 8 by 3, correct? Okay. 4 is. So R will be equal to what? Yeah. Let me check it. Did any mistake? A square into R cube is equal to 2 by 3, right? Okay. 9 by 4 is equal to 2 by 3. Yeah, correct. So this is gonna be 8 divided by 9. This is 27, right? Correct. So this will imply R is equal to 2 by 3. Correct? R is equal to 2 by 3. We found the value of A and R, right? So third term we can easily find. T3 will be equal to what? T3 will be equal to A into R square. So alpha will be equal to A is 3 by 2 into 2 by 3 whole square. It's gonna be 3 by 2 into 4 by 9. 2 1s are 2 2s are 3 1s are 3 3s are. So alpha will be equal to 2 by 3. They have asked us to find what? They have asked us to find 2 alpha value. So it's gonna be 2 into alpha equal to 4 by 3. Correct? So is it clear to you what we have done here? We have split our question, okay? Okay. We have split our question into two parts. First part may we consider a first statement, the sum of the first 4 terms of geometric progression. So these are the 4 terms that we considered. And we considered sum of it. And in the second statement, they are given sum of the respective reciprocal is this. We considered sum of the reciprocals also. So we got one more equation. What we have done? We have divided that equation 1 and 2 so that we can get value of this A square into R cube. Okay. After this, we made use of this third information. What was our third information? The product of first 3 terms of GP is 1. Okay. So, yes, using the third information, I found A value. A is equal to 3 by 2. And using this A is equal to 3 by 2, which I substituted here in this equation, I found the value of R. So when A and R are known to us, we can easily find the T3, right? It is nothing but A into R square. Just substitute the value. We got the value of alpha, multiply it by 2. We got the value of 12. So is it clear to you? Any doubt in this? Yes? YouTube students as well as Zoom students, any doubt in this? Well, very good. If there is no doubt, then well and good. So next one, this gonna be your homework question, okay? So try to solve this question. And there's next one more question. Take a screenshot of this. And there's one more question. Try to solve this both the questions. And yes, this will so here we will finish our chapter sequence and series. Okay. So from next class, we will start with what? Binomial theorem chapter. Fine. So as we completed this chapter, so your duty will be what? Your duty is to solve model questions. Whatever questions are there in model, please do go through it and solve it. Fine. In the models, we have AIEEE question, JEE, previous year JEE questions also. Please try to solve them. If you solve more and more, you'll be well versed with the topic. Here, I can give one hint. The hint is arithmetic mean will be always greater than or equal to geometric mean, okay? We made use of this concept here. So please try to solve it. And if you have any doubt, please let me know in the chat box. If you have any doubt in this complete chapter, let me know in the chat box. Okay. Let me know in the chat box. Okay. Fine. If no doubts, then well and good. So my humble request to you all to is go through the concepts and solve all the questions as much as possible. If you solve more questions, the time that you take to solve next question will reduce. Okay. If you solve that question in 5 minutes, next time if you're solving it, after solving so many questions, it might reduce it to 30 seconds, right? So please do practice the questions. Till then, have a nice day and we'll meet in the next class, okay? Okay. So bye-bye. Have a nice day.